interested. So. You're in the wrong room, Shabab. No, I think you're in D113. Are you going to test now? What time? Shabab, that was 5 minutes ago. Quick, go back up. I believe so, yes. Okay. Now, next. So, now, after we've... Please put the food away. Now, after we've identified our different types of data, now we're going to collect some. So we have a little bit of verbs, okay? Well, I suppose you might call this collecting data. What I call it frequency distribution or frequency.
Sorry, what's the name of the lesson? She's testing your attention.
She's testing my patience. That's what she's doing. Now, I just want to give you a little bit of vocabulary first. Does anybody know the meaning of this verb, tally?
Yes.
Yeah. What's it mean?
Yes.
Yes, very good, yeah. It means to count something, and not only to count it, but to count it using what's called strokes or tallies. Which, you know, you've seen these before.
Yes.
Now, I know different countries sometimes have different symbols, but I think this is pretty common here. So, for example, if I said to tally this data here, A, B, C, E, U, for example, so they're grades, right? So I'd write down A, B, C, D, E, and U. So let's see, let's do a different color. I got A, B, C, E, U. Now if I put in some more, let's put in 3 more A's at the end. And I have 1, 2, 3. No, well, I wasn't expecting that reaction of like, now they all make sense. I always wondered what those things meant. So there you go, that's the first thing, which is the verb tally. So if I just said tally up this data, it means put it together in a table like that. Okay, so
How 4 would do the dash maybe?
4, and then the 5th one makes the dash.
So the dash is counting.
Yeah.
It's the 5.
Yes, it is the 5. Yeah. Okay. Now, let's scroll down now. So, what type of data, by the way, were those grades? Yeah, which was qualitative? Ordinal, nominal? Ordinal, yeah. So, let's do another example now. Let me just ask everybody how many siblings they have. So, number of siblings?
4.
Brothers and sisters, in case you didn't know siblings. 4? Yes? 3? 2?
1.
Ah, no, that's too nice. That's too nice. Is it really?
Yeah.
Well, I know, Sarah, you're not 0, thanks to Hassan here. So, what? 4? So, Hassan, your answer better match Sarah's, or there's some problem here. 4 as well, yes?
Stephen!
What?
Do we count ourselves or just...
No.
Okay.
No. Wait, I'm not there at you yet. Sadiq? 4. Now, moving down.
4.
4. 5, I believe. 2. 5. I'll put myself here as well. 2. Okay, so what we're going to do now is put this in what's called the frequency table. That was the name I gave to the lesson, frequency. So what's a frequency table? Well, it's a bit like a tally. It's a very nice, neat way to put all this data together. So you just need two rows. So on the top is your possibilities. So we could have 0, but you notice that there's actually no 0 in this one here. 1, 2, 3, 4, 5, 6, and then maybe we'll just do 7 or more there. And then the second row you put down what's called the frequency, and frequency just means how many of them you have. So if I was to look here, let's see, how many zeros do I have? None. So there's none of those. Ones, let's see, there's 1 there. Okay, 2s, 1, 2, 3. 4s, no, sorry, 3s, 1. 4s, 1, 2, 3, 4, 5. 5s, 2, 6, and 7 plus 0. So this is now a frequency table or frequency distribution for this data here. Now, what type of data was those numbers there? Quantitative, quantitative what? Quantitative, discrete or continuous? Discrete. So, we've looked at a tally system is good for both ordinal and nominal, and the example I gave was ordinal, it was the grades. So we can have, let's just a little recap of the two we have so far. For a tally, we can use ordinal and nominal. And then for what I'll just call an F table, frequency table, we can use, frequency table uses discrete. So there's one type left now that I haven't shown you what to do with, and what's that one? Continuous. So for continuous, which is probably the most difficult of the four here, we have to use what's called a grouped frequency table. So that's what I'm going to do next now, grouped frequency table. Okay, can I scroll down or do you need a minute? So we've done tally is good for ordinal and nominal. Frequency table, what I just did, is good for discrete. And then the next one and the final one here is a grouped frequency table. Can I scroll down? Yep. Okay. Oh, Reem, is today, it's Annoy Stephen Day today, isn't it? Grouped frequency table. Okay, so the way grouped frequency tables work is the use of the word grouped here, meaning that each box there's a minimum and maximum. So you could put something into the first box if it falls within a certain range. So this is what it would look like. Okay, here's an example of a grouped frequency table. Whoops. Reem, now hang on, just be quiet and write this down. Sounds like a Shaggy song, isn't it? Right, okay. Let's say 0 to 9. Well, let's see, what example will I use? We could use heights, for example. No, because I gave that a question there. What continuous examples did I give you? Shoes are discrete and continuous. We'll take something from biology. So enzyme concentration. What's the unit for that? Moles per litre. Good, okay. And what would be the starting value? Could it be 0?
Yes.
Yeah, okay. And what would be the most you could reasonably expect? I guess, what? Well, like, what would be a high number you could get? No, what was that? Enzyme concentration. What unit is that? Moles per litre. So for the experiment you did, what type of numbers were you getting? 100 moles per litre or something like this?
Like most of them were like 70. Why did you
Shh, be quiet. Someone else is talking. Go ahead.
Between 20 and 70.
Okay, good. So if I go up to finish here at 100, that would probably cover everything, yes? Okay, so I'll go up 0 to 20, 21 to 40, 41 to 60, 61 to 80, and we could say 81 to 99. Okay, so this is moles per litre concentration of an enzyme.
90.
It can be whatever number I want.
Do you have to add to put the one?
Hang on. Again, Sadiq was in the middle of saying something. Then you can ask. Yes?
I thought you were following a pattern, sorry.
No. In fact, it doesn't have to be any particular pattern. They could, in fact, be different sizes. Yes. Now, what were you saying?
Because I understood.
Good for you. Okay. 5, 7, 2, 1, 0, something like that. So what you're saying here is, did you do this in like tubes or something, or what was it that you measured this in? Just different tubes, was it? So here, there's about, it looks like there's 15 samples here, is there? Is that right? Yeah, 15 samples. So what you're imagining happening here is, of the 15 samples, 5 of them were 0 to 20, 7 of them were 21 to 40, 2 of them were 41 to 60, 1 of them was 61 to 80, and none of them was 81 to 99. So you take your different results and you put them into one of these 5. So these are called bins. Each one of these boxes are called bins. But these numbers here will be called a class. So if I said, what is the class for the first bin? So that's your vocabulary, okay? Class would be the numbers, whereas bin would be, like the physical box. So we don't say box, even though it is a box. We say bin, firstly. And we don't say range or numbers or words like this. We say class. So you could say, where does the class start? Starts at 0. Where does the class end? Ends at 20. Yes.
Cell as well.
Cell is more of an Excel term, but cell is okay. Yeah.
When you just said where does it start? You said the class starts at 0 and ends at 20.
Yeah.
You're speaking about this bin.
That particular one, that bin, yes. Okay. Now, that would be an example of a grouped frequency table. So, let's suppose I have my 15 and now I do another experiment, and let's suppose this time I get 63.21 moles per litre. Which of the bins would that go into? First, second, third, fourth or fifth? Yeah, that would go into here, and then that would up to now 2. Now let me give you one to get you thinking. What about 20.6? Which one would that go into? The first or the second? Or go into the second one. Now what you realise now is you need to be very clear about when does one start and when does one end. So the next thing I'm going to show you now is what's called the class boundaries. You know this word boundary? So the class boundaries is literally what is the exact start and end. So if you look at this one, you realise that you kind of finish at 20.5. But suppose you got 20.5, would you go into the first or into the second?
First one.
You go into the second because 20.5 rounds up. So is the 20.5 actually included in the first bin? It's not. So we say it's open here, and then 0, we close there. Now the next one would be 20.5. Is it included?
Yes.
Yes. And then where would it finish?
40.5.
Very good, 40.5. And again, that's the second class boundary. Yep.
So what you're saying is that 20.5 will not be included in the first one.
Yes, yes, yes. But it's the beginning of the next one. So these class boundaries will be very important later when we're drawing graphs. But right now, you just need to know what they are. And really, you can see that it's going to be the middle of these two numbers here. So, well, that's all it is, class boundaries. Yes?
How did one change to 61 to 80?
60, how did which one?
It was one previously.
And now it's 2. Because what I imagined is I did another experiment, so I got another result here, and that went into this box. So that's called class boundary. There's two other things now to do with these classes. So we know the boundary. What do you might think would be another thing that we might want to know about the boundary? What do you think? What else could we know? Or what else might we want to know about each boundary? Any ideas? Very good. It's called upper and lower boundary, but we won't worry about those terms just yet. But you're right, upper and lower boundary, or upper and lower bounds. But what else might want to know about a boundary? Like, what else could we know if we have a start and an end?
How many?
Not quite how many.
What kind of graph?
Well, we might want to know how long it is. How big the boundary is, yeah. Well, that's not going to be difficult to find. If you were to write down a formula, what would it be? If I give you these two numbers here, and you want to know how big they are, or how long it is, what would it be? The bigger one minus the smaller one. So in other words, the upper one minus the lower. So what would it be for the first one? It'd be 20.5. And then for the second one? It'd be 20, it looks like. 40.5 minus 20.5. And again, I think Sadiq, you were saying, they don't have to be the same length. So here you can see, in fact, it's not the same length.
Why are we doing this exactly? To know the length of...
Yep, to know how long each one is, yeah.
I thought when you doing the class boundaries to make a graph, I thought you have to be in the same pattern.
No, they don't actually have to be, no. No. No, they usually are. There's no rule that says they have to be a certain pattern. And there's one last thing we could know about each class. Anyone got any ideas that another thing we might want to know about each class? So we know where it starts, we know where it ends, we know how long it is. What else could we know or would want to know, do you think?
The center.
Yeah, what did you say? The center, yeah. What's the middle? What's the center of each boundary? So how could you find the center, or what we call the midpoint? Very good. You add both, so it would be the upper plus the lower divided by 2. So in a different colour here, the first one, what would that be? It'd be 10. Very good. And then this one, 40 plus 21. Oh, well, actually, no, it wouldn't be 10 for the first one. It'd be 10.25. Thank you. The lower plus the upper, 10.25. And then this one be 20.5 plus 40.5. That's 61 divided by 2, which is 35. 30.5, and so on. So these are called the midpoints of the classes. So now we have the lower boundary of the class, the upper boundary of the class, the length of the class, and finally the midpoint of the class. Yeah, that 10.25 was 20.5 plus 0 over 2. And the 20.5 was 20.5 minus 0. So I'll just put a little note here, sorry. These ones were the lengths, and then these ones here were the midpoints. And then these ones here were the boundaries. Can I scroll down? Yeah. Now, just so you're not confused in the exam, it's quite normal in the exam that they just put this vertically instead of horizontally. So here would be the data, and then here would be the frequency. So for example, you could have 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 100. I've put in some numbers.
If you were to calculate the length and the midpoint,
Yeah.
find the bounds.
Exactly. Now that's what I'm going to do here. This is a very, very, very typical example in the exam. In the exam they would say, extend this table, and they want you to extend it to include the boundaries, the midpoints, and the lengths. So you take this table, you redraw it in your book, and then you put the extra piece on. So what extra things do we have? Well, we have the, whoops, hang on, let me get this here. The lower boundary. What else? So I'll just write lower. Yep. And then what else? Upper. And what else? Yeah, I'll do length next, and then finally is the midpoint. So for example, here the lower would be 0, and here the upper would be 9.5, and the length would be 9.5, and the midpoint would be 4.75, right?
It shouldn't.
Oh, you're right, sorry. 4.5 and 4, no, 4.75.
Actually,
Yeah, it's okay. Yeah, it's okay.
what if you, instead of writing low and up, you write class boundaries and make 0?
Oh yeah, like if you wanted to, you could have actually, instead of writing that, you could have just put in these and just called this now
Class
boundaries. Yeah, class boundaries. Yeah, that's fine too. I'm looking for the numbers, you know, and then that just continues down. You know, that would be 3 marks. Something like this could be a 3-mark question. But you realise once you have the first one done, it's really all the same.
So the low for the next one is 9.5?
Yeah, then that would have to be 9.5 for the next one, and then what would be the upper? 19.5, and so on and so on. Part of the reason I'm doing this is also just so you have seen the fact that frequency tables can be written horizontally or vertically. In fact, the reason it's done vertically is so that you can write this extra information in. Whereas when I last did it here, it was very difficult to write my extra information in horizontally. That's why in the exam they give you the table vertically. So in your answer book, you copy the table over and then you add this in. Now, just so you know, there'll be one extra thing here, which I won't do today, that has its own lesson. But, whoops, maybe some people have heard the word before, so I'll just say it, but it's not for today. And then that would be it for the table. Something called cumulative frequency. Does that ring any bells for anybody? You've heard this before, cumulative frequency? Anyways, that's not for today, but just so you know, there is still one more column to put into this table. Okay. So, what I actually have not done yet is I haven't taken some data and put it into a group frequency table. So how do you make your very own group frequency table? So let's do that now. Can I go down? Yeah. Right. Does everybody here know their height?
Yes.
Could you know it roughly?
In centimeters.
Yes, please.
158.
Okay. So taking her as a benchmark, are you taller or shorter than her? No. This person here. Yes. So just subtract a couple of centimeters, okay? So just get it. It doesn't matter if you're inaccurate. I just need to make some numbers. So go ahead. Whose height are you roughly the same as?
Stand up, we'll give you.
No. Would you be the same height as Miranda? Right, Miranda, what's your height?
You're 167.
All right. Do you want to be 170? Why not? Okay, 170.
170.
Yeah. I'd say 1.70. I'll do it in meters. What's yours?
150.
Okay, that's fine. Yes?
What? You're 1.
Are you the same height?
No,
It does look.
She's 150.
You know what? Fine.
156.
He doesn't care.
Yes, you're right. I really don't. I really just need numbers, okay?
158.
Okay, 158. Miranda, give me some. 1.6. 7. Sarah? Okay. Hassan? Hey, focus here. 180. Sadiq?
No need to brag, but 5
You're 5 meters tall and 20 centimeters, yeah? You're 5.2, yeah? 5 meters and 20 centimeters. Right. How about giving me the actual number?
Yeah, 1.4.
1.4? You really have no clue what you're talking about. I'm going to make you, what do we say, 1.7? 175, yeah. You?
153.
Yes.
No, Sarah's making up what's on the jet side.
I don't actually care, I just need a number. Go on.
158.
Okay. Curdy? I think, yeah, for sure. Good for you. All right.
When I look at this, I say,
Are you saying you're the same height as Sadiq? All right. If you want to be, we can all dream.
Oh, really? Then can I change my height a bit to 2 meters?
There.
wow.
Yes.
That way.
Huh? No, that she wants a 2 as well. Yeah. I can include your real and your fantasy one as well, okay? Now, let's see how many have I got here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Don't you want to include your height?
I don't actually know it.
Don't be shy.
Would I be the same as Sadiq?
No, you're taller than her.
Are you 175? I don't.
179.
Yeah. Why not? I need to make 16 as for my example. So how many have I got now? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13,
195.
14, 15. All right, 195,
185.
185.
And 155.
Sure, fantastic. Yeah, who are these people? And then Joseph. Roughly, yeah.
He's not that far.
Huh?
He's not that far.
No. Okay, now, how do you make your group frequency table? So the first thing you need to know is how many bins you need for it, okay? So you first have to count how much data you have. So here I have 16. Now the reason I picked 16 is because there is a formula for how many bins you should have, and the formula is the number of bins should roughly be equal to the square root of how much data you have. So that's the reason I picked 16 here, to make it nice and clear that I have 4 bins. Okay, 4 bins. Now, once you've done that, you then have to see the smallest and the biggest value to know where to start and to end. So the smallest one here, and then the biggest one here. Okay, I have to zoom out a bit. Smallest to biggest. Okay, X and F. So we know that we absolutely must start here, and then there'll be that, and then we must finish here. So can you just have a calculator for a second? Let me actually...
What's 1.2?
The starting one. I'm just leaving in a blank spot now. Whoops, wrong way around.
Don't you want to do it?
Square and then round, square, round, square, round, square, bracket, or comma, round. Right. So if I finish at 2 and I start at 1.2, that's a difference of 0.8. So the difference between the biggest and the smallest is 0.8. Okay? How many bins do I have? 4. So I should divide my 0.8 by 4, and that's how much I have to go up in. I have to go up in 0.2s. Yes? So here would be 1.4, 1.4, 1.6, 1.6, 1.8, 1.8, and then 2.
How did you get this number again?
It was the biggest minus the smallest divided by how many bins I need. And I got an answer of 0.2. So I'll go up in 0.2s. So 1.4, then 1.4, 1.6, 1.6, 1.8, 1.8.
Square one. The last bracket, shouldn't you make it a square?
A square?
Square bracket.
Oh yeah, actually you're right. Sorry Faisal, it's because we do have a 2 here. So I'll make this one square at the end. Okay, so now we can fill in. How many 1.2s to 1.4? So let's see. 1. Just the 1? Okay. Now 1.4 to 1.6. So now 1, 2, 3, 4,
5.
4, 4. Oh, 5. Okay, 1.6 to 1.8. 1, 2, 3, 4, 5, 6, 7.
8.
7. And then these two, 1.95 and 1.85, go into the last one.
And you didn't have the 2.
Oh, yes. So that's a 3 then.
We're just counting how many, not the ratio.
Just count how many, yeah. Okay? Now, we know that usually when we get a frequency table, it's not listed with the boundaries. It's usually listed as number to number, and then we have to add in the boundary. So now we have to kind of work backwards just to finish this here. So if I draw the table again, okay, so if I start at 1.2 and I finish at 1.4, what numbers, hang on, let me make lots of space here. What would be my two numbers I would need here? Well, it should be, remember, a little bit smaller than 1.4 because we rounded up to get the upper boundary. If I go back to my example here, you see here the class boundary was 20.5 and the number we saw on the table was 20. So I need to go down a little bit. Yeah, well, I shouldn't use 1.4. What should I use? 1.35. Very good. Because if I was to round that up to one decimal place, what would it be? 1.4. And then what?
What
Yes?
are you doing this? Why are you changing the numbers?
Because these are the boundaries, and we don't want the boundaries. We want what would have been the original. Now the 1.2, what should I use there? Well, in fact, because it's the first one, it doesn't really matter too much, but if I want to make it a 1.2 here, 1.15. Yeah? No, you're looking a bit confused. Yes, no. Going backwards is difficult, I know.
What's it called? Changing the boundary?
No, this was the boundary and we want the original. So if this was 1.4, what would I write here?
1.35.
Okay. Hang on. Let's go back a little bit. We'll start this over. You seem very confused. And I don't know if actually you did that right. So firstly, if you remember how these go, this number here should be one bigger than this number. So if we go back to my table here, you see the way I had 21 and 20 here. How many decimal places were here? One decimal place. So if you had not got one decimal place, here is 0 decimal places and here is 1 decimal place. So you lose a decimal place. So here actually, how many decimal places? 1 decimal place, isn't it? Yeah?
Making values should round up numbers, so there's 2 decimal places.
Yes, so here, well, my question is, what number do I put here? I need a number that is between, that 1.4 will be the middle of this number, these two numbers. So imagine a number here and a number here, so that the middle of it is 1.4. So yeah, that could be 1.35. So then what would have to be here? 1.45, wouldn't it? But they don't match.
Yes, it should be 1.
It doesn't match up.
Because the first one should be reduced by 5 and the next one should be added.
Yes, okay. Chill, Sadiq.
I don't understand.
No, that's why I'm doing it again. Alright, starting over again.
So you're supposed to add those numbers to get 1.4?
Just give me a moment, okay? I'm trying to think of the best way to explain this to you.
TYT.
Yes. So 1.4 was going to be the middle of two numbers here. So as an example, let's just put in a couple of different numbers. So for example, if I put in 1.39 and 1.41, would that be the what would be the middle of these two numbers? It would be 1.4. Now, for example, I could have put in 1.35 and 1.45, right? Now, what's the middle of these two numbers? 1.4 also. So we need two numbers that have a middle of 1.4, and there's many, many choices. And as Hassan pointed out, this one here is 1 decimal point. Okay? So it would be wrong to use 1.35 and 1.45. The reason is usually they just step up by 1. So if it was 1.35, the next one should be 1.36. So we need two numbers so that the middle is 1.4 and they're back to back, they're neighbours. So what would that have to be? Would have to be 1.39 and then 1.41. The middle is 1.4 and they are back to back, yeah, except for the one missing in the middle. Like in my example here at the start, see? 20 and 21 are back to back except for the one that's missing in the middle, which is 20.5. 1.39 and 1.41, what are they missing in the middle? 1.4. And they are back to back. It's not like I'm skipping a gap. So here is 1.39, here is 1.41. Now let's look at the next one. What would that be? So the middle needs to be 1.6. So what do you think I'd put here? 1 point, very good. And here?
1.6.
Good. And then here?
1.79.
8.
1.
Now, you've got to remember, there's no problem with the start and the end. If you want to put 1.2, that's okay. If you don't, that's okay. If you wanted to put like 1.1 something. But just to make it easier, there's no big deal with the start and the end, because it's the start and the end don't connect to any other bin. So you can just make your life easy and say 1.2, and then here would be 2. One, 5, 7, 8.
Do each of those ways to do it that way?
What do you mean?
Like, can we ask us to do it like this or do it like this?
I've only done it one way.
No. The first one is like
Oh, sorry. No, the different names between these two. Yeah. The one at the bottom is called a group frequency table, whereas the one at the top is still a group frequency table, but with the boundaries. Yes, wait, hang on. Curdy had a question, then go back to you, and then you. Oh yeah, sorry. Thank you, Curdy. All right. Back to you.
So they would give us the one at the bottom, and then ask for the boundaries, and then ask for the length and midpoint.
Could really go in any order. They could give you the data, and then ask you for this and ask you for this, or they could give you this one and ask you for this one. You know, the order, it could be anything. Now, I will tell you though, in every single exam that they've ever given you, it's always been from here to here, which is a lot easier than the other way around. And also in every single exam, in section B, they have never, ever given you the data. They've always given you the table. So in fact, I think it's almost impossible that they would give you a blob of data and ask you to put that in a table. They've never asked you to do this. Never. It's always been the case that they give you the grouped frequency table and then ask you questions from it, like what is the class boundary, midpoint, length, and so on. But I need to show it to you just in case they give you data and they do say put it into a group frequency table. Now, by the way, if they said put into a group frequency table, you could actually give your answer like that or like that. So you don't even have to make this table. You can just finish it with the boundaries. You don't have to try and go back to the very start. So it is not necessary to do this if they ask for a group frequency table. You can actually just do it like that, which is a lot easier. The reason I need to do this is I don't really know. I just wanted to, so there you go. Yes.
So it doesn't mean that the amount or the number of values you take from the first one is what you add to the next one, because you remove 1 from 1.4 and 0.1 from 1.4 and then to 1.4.
How did I get the 1.4 basically, is it?
Because I was thinking that you must have removed 0.1 from 1.4 to get 1.39. and added it to the 1.4, so it's back to back.
Oh, okay. You want to think about it like this, is it?
And for the first example, it was 20.5.
Yeah, okay.
20.5.
If you want, okay, this is 1 decimal place. So the next one will be 2 decimal places, which would be 0.01. So yeah, if you want, it's both plus and minus this onto each of these numbers. So plus to give you the the start of the next one, and then minus to give you the previous one. So yeah, if you want to think about it as plus or minus that, and this number is always 1 extra decimal point than the boundaries. Like this, if you like. Yes?
It's always the case where it's always 2 decimal points.
No, it doesn't have to be 2 decimal points. But usually in the exam, it is like this, yeah. In fact, I think it's always 1 or 2 decimal points, yeah. But I mean, it would have been much more difficult to imagine, but it could have been, for example, the boundaries were 3 decimal places, and then the next table would have been 4 decimal places. So instead of having 0.01, you'd have 0.0001 plus or minus. I promise you this is the small thing in the whole exercise. For the exam, what do you need to do? For the exam, basically you need to do one thing, and that one thing is write down one idea, which is to extend the table. That is to write down the lower boundary, the upper boundary, the length, and the midpoint. That's what they ask you to do in the exam. They never ask you to make a table, because it would take too long to do in an exam when you have 25 numbers. Now I'll just give you a couple of minutes to try these. But do number 7 first, and then go back to 1, because number 7 I ask you to tell me what the boundaries and midpoints are. Back to Kirby, please, and then there's a couple more. Oh, very true. Please do 7A now. So tell me the boundaries of each class and the midpoint of each class.